Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at overloading the left bit shift operator, and the value in doing that is as follows, and it has to do with printing. So if we create a object here, I'm using the class from the previous tutorial, except that I've got rid of all the couts in it. So we've got a copy constructor, assignment operator, a print function to display it. We've got a default constructor and a constructor that takes two parameters, and the class has two instance variables. So we're going to use this. Let's create an object called test1, and we'll supply it with an ID of 10 and a name of Mike. Now at the moment we can do test1.print. So if I run this now, then we get this. But what would be really nice is if instead we could do this, cout test1, and perhaps endler there. So how does this expression actually work? Well, if you look at this operator here, let's look at this one to start with. It seems to have two arguments. So one is cout, and cout is actually an object of type osstream. That's output stream. That's the class, and this is an object of that osstream class. Test1, of course, is our class up here. So this operator seems to have two arguments. It seems to have an osstream, and in this case a test, an object of type test. If we look at this here, your first thought might be that, well, this has two arguments, and they are the first argument is an object of type test, and the second is this endler thing, whatever that is. But in fact, some operators in C++ are right-left associative, and others are left-right. So if we do something like int value equals 1 plus 2 plus 5, let's say, plus operator has right-left associativity. That means we're first going to do this, and then we're going to do this. So if I put brackets around that, that's exactly the same expression, but it's different with cout. With cout, it has left-right. With the bit shift operator. The bit shift operator has left-right associativity. So it's as if we are doing this. Let's see if that actually compiles. I've never actually tried it before, but no, that doesn't work. But it's as if, although you can't use brackets there, nevertheless, what's going to happen here is first we're going to do this bit. So we're going to do the left bit first, and then we're going to do this. So we have left-right associativity. And in fact, this expression returns an object which is a reference to an osstream. And then this is being, this operator then has two arguments. It has osstream, and then the second argument is this endler. So in both cases here, the first argument to this operator is this osstream, and the second argument, well, in one case is test1, and the other case it's endler. Now, because the first argument to this operator is not of type test, we can't implement this as a method. If we implemented it as a method, the implicit first argument would be kind of like this. It will be a reference to the object that we're working on. We have to implement this as a function which overloads the meaning of this left bit shift operator. So to do that, we're going to have to make this a friend function. So we've seen briefly before that friend functions are functions that are not methods of the class, but they are allowed to access the class's private members. So here, let's take a look at formulating what an overloaded left bit shift operator to make this work would actually look like. So it's going to have to return a reference to an osstream, because we're going to do this, and that's going to have to return an OSTREAM to a reference to an OSTREAM, so that we can then do this. This is actually like calling a method on OSTREAM and passing it endler, just as this is like calling a method of OSTREAM and passing it test1. So the return type is going to be OSTREAM reference, and that's OSTREAM is the type of cout. Then we have the operator keyword, operator, and we have the left bit shift operator, which here is already overloaded. If we put an int in there instead of a test, this would work, of course, or a string, and it's overloaded already for those classes, but it is actually the left bit shift operator. Now the arguments that it's going to take are going to be an OSTREAM reference for the first argument, which we'll call out. So this is the first argument to this operator. The second argument is going to be an object, a reference to our test class, and we can make that const because we don't want this to actually change it. Let's call it test. Now I'm going to have to, in order to display test, I'm going to have to access its private instance variables up here. So there are two ways of dealing with this. One is that we could provide test with get methods, and we could just call public get methods, which we could just call here. The other possibility is that we can just declare this a friend, and that will mean that it's allowed to access test's instance variables, private variables, and private methods as well, for that matter. So you might think, well, I don't want it accessing private methods, so I'll just declare getters for this, make them public, then I don't have to make this a friend. And if you did that, you could declare it outside of the class. So normally, of course, we put the implementation in a separate CPP file. I'm just doing this here because it's easier to see in this tutorial. But this implementation, the actual implementation, should be in a separate CPP file. So the implementation would look like this bit here in your CPP file, and then you just have to put the prototype, which is this bit here, in your header file. So in your actual class declaration in your header file, and you need friend in the class but not in the implementation. We'll look at friend a bit more closely later on. So let's implement this now. So we can use out our OSTREAM, and we can write to it test.id, and we get to choose how we're actually going to do this, how we're actually going to make this look nice. Let's maybe put some punctuation in and write test.name to it as well. We don't want to put an endler in there. We could do, but we don't want to, because we want the user of this to be able to choose whether they're going to put an endler there or not. So let's now return out. So that's being returned as a reference here. And now this is going to work. So let's try it. Let's build the project and run it. And we see we've got Mike there. We could even do stuff like we could declare another test object here, Bob, and there's no reason why we can't do this, because let's take a look in a second, but if we run this now, it still works. Doesn't look very nice, because this bit is being evaluated. It's returning a reference to the OSTREAM. Then we're calling the function again with the OSTREAM as the first argument, which we returned here, test as a second, and finally we're doing it again, where we're calling the OSTREAM returned here, and we're calling it with the arguments test2 and endler. So this all works. So that's it for this tutorial. I've given you a lot of details here, but again, the thing to do to get your head around this is not to agonize over the details of it. The thing to do is to type it out. Try to think a little bit as you're typing it, because once you can type it from memory, then it's a lot easier to then understand afterwards what's going on. And I'd recommend, so try this for your own class, implement this for a class of your own. It can be the same as test or different, it doesn't matter. Get this to work and try getting to the point where you can type this from memory. And when you've got there, then if you didn't understand everything in this video, you might want to watch it again. And once you've got it in your head what the actual syntax of this is, it's going to be the things I've said are going to be a lot clearer. So in my view, it's a waste of time to make detailed notes and try to memorize everything as you go along. It's much more efficient to first memorize how to type this, even if it will only stay in your memory for a short while, and then afterwards to understand how it works, in the same way that when you learn a language, it's easier to first memorize phrases and then afterwards understand the grammar, because after all, people learn to speak their native language without even understanding the grammar at all, really. They just memorize lots of phrases, they see how it works, they gain an instinct for it, and afterwards you can study grammar and learn how it works. So typing is the key, at least in my view. Now we've done this, we can get rid of the print method, of course. So that's it for this tutorial, and until next time, happy coding.